Right. So today's session, so is part three of uh all the all the webinars that we're doing this quarter. So we have three webinars planned for this quarter. This is the last one. Okay, so today's we just focus on, so we've been doing the design parts in the first one, and then the second part is more towards the additional parts from the designs to collaborations to simulations and all. So the last part is how to basically from your equipments, so all your building products, so how do you collaborate or how do you share your equipments to the BIM team, or to make it BIM formats in a way so that it can be used by Revit and any other applications. Okay, so again, my name is Said. So what is BIM? So this is a very quick run through. So this session was supposed to be for all the manufacturers of building products and equipments. So what is BIM? So usually it is understandable that BIM is building information modeling, but usually for manufacturers or for factories, they are just like not sure what is it about. Okay, it's just too for architects, but nowadays even BIMs are related to manufacturers. So manufacturers are now supplying all the equipments, all their products, all their machinery to buildings related models. Okay, so basically it's just a process. It's not a tool, so it helps to identify all the clashes, coordination in the process of building up a building or infrastructures. Okay, who involved in BIM? So it's, as you can see on the right hand side, it's not just one person, it's not just the owners or the architects, so it's basically everyone. Okay, but in this particular session, so we'll be focusing on the builders and the manufacturers of the building equipment. Okay, so convergence between BIM and manufacturing. So here is where building products or building equipments are working closely with building design to make sure that you can reduce all the clashes, all the amendments, to reduce all the amendments that usually required during the construction processes. Here is just some of the example of the manufacturing component in BIM. So building products and equipment. So you probably should fall in some of the parts in here. So building product and equipment, custom fabrications, building or equipment layouts, modular constructions, or maybe even some AEC engineering related. When dive in a little bit more, so a manufactured component of a building. So this is the target of these sessions today, for all the building products that is manufactured on factory and then built and assembled before delivered to site. Okay, so basically, so in general, it's all related to the prefabs, any custom architect or structural components, a curtain wall, every custom furniture or custom caseworks. Trend nowadays, so everything is prefabs and productization. So prefab means already pre-manufactured in a factory. Okay, or people are selling their stuff or their product as a set, as a bundle to be sold as a system. Okay, so advanced building products, single thread assemblies, multi-thread assemblies, or modular. So this is the prefabrication continuum. So this is all the fabrication related things. Okay, so let me adjust that. So modular constructions. So we don't see much here in Malaysia, but they are already started a trend that modular constructions are coming in, okay, into this region, the ASEAN region especially. Okay, custom fabrication. So all the nice buildings now design and build or pre-built somewhere. Okay, so a building equipment that's been modeled, okay, and sheds, industrial machinery that is part of a building. Okay, so this session we'll see how to make sure that all these equipments, all this machinery can be coordinated correctly with the building design itself. Okay, so building product, equipments, prefabs is on. Okay. So some trends and drivers. So before we start, so sustainability. So every building, even building themselves, building design themselves, they need to think of sustainable. So they need to go design or construction to according to the sustainability efforts. Okay, BIM. So whatever building now in Malaysia, so Malaysia is following BIM mandates. So whatever building design is need to follow BIM mandates, and all the products, building products and building products equipments need to make sure that they are able to send or to share their products or their equipments in compliance to the BIM standard. Okay? Digital construction, industrial construction, smart buildings, and regulations. Okay. Just go direct here. So the design collaboration. So of all whatever I've shared earlier in this session, so design collaboration is in the middle of all the mentioned earlier. Okay, so constructions and manufacture, these are two different industry where definitely two different company where need to collaborate and coordinate their equipments. So one have building design, one have product design, which they need to retrofit it together to make sure there are no clashes that will affect the construction processes. Okay, so usually, so with Autodesk solutions, so the Autodesk solutions that is involved in this process is Inventor. So Inventor is the only application that are able to bring in Revit files and directly and collaborate with Revit files directly without even converting or importing. And Inventor is the only software that are able to send or export to few of the famous BIM formats. So especially Revit formats, so Inventor are able to export to Revit formats, even Revit family format and IFC, UIDSK, and so on. Okay, so part of the benefits of using Inventor for this industry is, so if you are in the equipment design, so you probably have multiples or a lot of the variations of all your designs and equipments. So whatever it is you're designing, so you can automate the design variations accordingly, and you can amend accordingly so that it can be easier and faster to go to market instead of manual changes. Okay, so BIM interoperability. So this is one of the strengths of Autodesk Inventor Professional. So Revit and Inventor collaboration through a medium we call docs. Even without docs, you are able to do it. But in this example, will show the collaboration with docs in the middle. So whatever design equipment that you created, okay, in whatever file format, so Inventor are able to bring in or open up that files, okay, either import it, make it Inventor formats, or keep it as the native formats, okay, and then simplify. So model simplification, all this machinery, all these equipments are very details, okay, because they are manufactured, so they need to be detailed. So all this will be usually designed one-to-one with all the bolts, screw, and nuts properly. Overall, having more than 500 plus components in. So, but to collaborate or to share to external party, or to, let's say, to be used by the BIM modeler or architects, we need to simplify it down. Okay. So you can see the image on the right hand side. So the top one is the so-called complete models with all the pipings, all the vessel, the pumps, and everything. But in reality, the building modeler do not need all this uh, detailed equipment. So what they need is the size, the correct size of the equipment, the inlet and outlet that is going to be used to connect two other equipments, so that it can be modeled or can be used as the inlet and outlet. Okay, so in this case, so we simplified these representations by removing 90% of all the detail components, keep just the basic features. So all the details of features are removed. If you can see, they're not even as at the bottom image, they're not even screw holes there, all been removed to make the file simple and light. So in this example, in particular, so the connection points are preserved, maintained, okay, and then from the 20 megabyte of stat file or whatever file format there is, 20 megabyte, it is simplified down to 650 kilobyte when you export it as a Revit family. So it's lightweight. Okay, so if somehow an amendment or adjustment are required, so you can still go back and amend the original master file. So you're not sending in the master files to the architects or to the BIM modelers. Okay, so AnyCAD for Revit. So what it means is the connections between Revit is kept so that whenever that there's changes in the building, size, measurements, or positionings, it will auto reflect back inside Inventor if we open Revit files from within Inventor. This is to maintain the sensitivity, okay? And then we can also select custom view. So we don't have, let's say I need some of the building areas to put my equipment. So I don't have to get the whole building, but instead I can specify maybe just first floor or just whatever floor or area that I need to. Okay. So on the right hand side, the most right hand side, we can see that this is how, let's say I open this Revit file. So this is how it looks like, the hierarchy of the files. Okay, the doors, so where are the doors, where are the walls? It is stored as similar, following the Revit hierarchy, files hierarchy. Okay, so Revit to Inventor Exchange, with Data Exchange, we can view and filter whatever data that we wanted. We can consume and make changes to the data. Okay, whatever changes, we can get notified and we can preset whatever notification that is required. We can understand the versions, the versioning. So they are versioning also in these examples, and we can visualize the changes. Okay, so now let's go to the example. So apply data exchange to control, share, and access the data that you need. Okay, you don't need everything, but you can simplify to whatever you wanted. So file formats, there are a lot of file formats and connectors. Okay. Okay. Okay, so from Revit, on the left-hand side, we have Revit. So we want to import Revit file. We can specify the area. So what is the area? So what is the view that we wanted? And you get for Revit. These are around since 2021. So if you are the user for both applications, or are you aware or you aware that you are using this Inventor or Revit? So this connectivity has been around since 2021. So I mean it's been around for some time. Okay. Data exchange with data exchange from Revit. So let's say now this is an example from Revit. So what I can do, I can specify. So I just need some, in this case, the emergency stair. So we can specify just emergency stair and share that particular area data exchange without even sharing the whole building. Okay. So now after we shared from Revit, we shared the data exchange of the stairs. So now I'm opening up in Inventor to use it as my reference for positioning of my equipment. Okay, that's how we can collaborate. An example, they have changes on the building size or maybe the door positioning updated in Revit. So the one in Inventor will also get updated. Okay. So here example. So from Revit, so we are sharing these files. So let's say I'm sharing a data exchange of this particular area. Okay, maybe I just hatchback supplier collaboration because I need the hatchback model to be in. Okay, sharing this data exchange. So specify whatever view I wanted to share. Created data exchange. Okay, you can see there are versioning and I can share it, access it from the web. So now this is a view from web. So I can share this to all the related person in the projects. Okay, so whoever have this data exchange link able to collaborate. So let's say now I'm the hatchback supplier. So let me load it. So I load the file that is shared from Revit. So this is from Revit. So I want to place my equipment next. So let's say I'm placing it on the BIM. So now I'm placing in my air chiller unit. Okay, air chiller unit on the BIM. So now I can share the view again. Okay, to check whether is this acceptable or is this okay to proceed with this. Okay, so now all this sharing are done through cloud. Okay, so we can give comments. So let's say the reviewer, you need to check and see comment, or can we add a beam to spread the load of the unit because the unit is heavy, so might affect the structure of the building. So now go back to Revit. I make some changes, adding in some beams. So in Revit, so once after adding that beam, okay, you can see that now it's shared. Now I collaborate and create the data exchange again. But instead of creating new, I update the previous data exchange. Save it. So now, once I update this in update this, so we can see now in Inventor, back in Inventor, so I just refresh it. And I can just refresh the files, the Revit file that I bring in. It tells me there's an update of the Revit file. So now you can see there are new beam added to help spread the load as requested. Okay, so this is done without even having to reshare the files or resave the files. So this is all done on the fly directly from Revit. Save, just update the data exchange earlier that was done in the first place, and it gets updated in the Inventor file. I mean, the Inventor user who use that Revit file as reference to place their building equipments. Okay, so now how the data exchange really works. So now from the right hand side, so let's say from all the Revit or the BIM model or the MEP designer or engineer, they design it in Revit. If let's say you are having doing a factories or some sort, or maybe a process plant that was done in Inventor. Okay, so we can also export the files or publish it in ACC. So that is what's done previously. Now with data exchange, it can be done directly. So we do no longer needed a medium to have import and export. It can be done directly with data exchange. Okay. So with data exchange, so it reduces the effort and the number of files that you need to collaborate from between building related files, building related design to equipments. Okay. So that is that. I mean, we're using the method that we are using earlier is the data exchange through Docs or BIM Collaborate Pro to link between the two worlds of the manufacturing and the constructions. So this is the process. But now let's go back a bit. Let's stop and step back to do so that I can show that we can also create without data exchange. We are still able to do this, but in a manual, not to say too manual, but this feature or this format has been around for some time. Okay, so we can, so Revit have two types of content or two types of family, which is dynamic. The one that in this example, the window, you have multiple of sizes. This usually means this files or this family is done from within Revit. So another type is the static BIM content, where the content, okay, or the library is created outside of Revit, probably with a third-party application, maybe with Inventor or with other applications that having the a better design capabilities to do equipment or machinery, because Revit is mostly focused on buildings. Okay, let's just use Inventor as the example. So from Inventor, I can create BIM content by exporting it to BIM content. So from Inventor, so basically we can, again, simplify, specify connector. If there is any connector, pipe connectors, power, electricity, you can export it as a RFA or RBT or IFC or even IDSK, so that the BIM modeler are able to reuse it. To enable customers to download BIM models. So if you are in the industry that do this building equipments or building products, so you can start to build your own BIM library or BIM content. So let's say whenever your customer requested for your cooling tower in BIM format, so you have it ready. Or if you don't keep it, maybe you can just create the BIM formats on the fly and send to your contractor or to your whoever requested for the files. Okay, so this is the process. So it doesn't involve any docs also. You can do this manually by save as all the RFA, IDSK, or the Revit files locally and reinsert it inside Revit. You can do that. But if you have Autodesk docs, you can also load it automatically. But this is also doable without the ACC and also Autodesk docs as the medium. Okay, so now coming back to the Inventor. So even though we use Inventor as a medium to send to BIM format, Inventor are able to bring in all these file formats, maybe even more. This is all the famous one. The Inventor can open. Okay, Inventor can compute all this and export it to whatever BIM format that is required. Similarly, like how it works with the earlier example, the Revit example, it works similarly with all other applications that is shown in this screen as well. Okay, a circular workflow supporting project-based work, because understand that a building equipment is not something standard. Most of the time it required custom work because it depends on the project requirements. Okay, so now we are bring in the building design done by architects, structural designer, MEP engineers, and all the manufactured solutions, systems, or equipments. We bring it together so that we can work together, collaborate better, so that to reduce a lot of the issues halfway across the projects. Okay, so now, as an example, so from this example, what I can do is we can simplify. Okay, I can simplify this unit. Okay, maybe removing all the details. You can see the fan on top, they have a lot of profiles. Okay, it looks very nice, but this is all required memory and size. So when we simplify it, we just remove all that because it is not required when we want to send or share it to Revit. So we simplify what we can simplify. So end up it's just some simple box with inlet. Okay, create simplified parts. Okay, and then I can just from within Inventor create a BIM content, alter a BIM content, specify what is the product classification. So the Omni class for this. So this is ASU. So ASU, what class? So who is the manufacturer? What is the website or URL, whatever. So just put it all the information in. Then specify a connector, a pipe connector. Okay, what's the diameters? So what is this outlet is about? Then the next step is as simple as you export the file to Revit files or to whatever files that you require. And I can insert it from Revit by loading a family. And now I'm placing it in Revit. You can see that that is the model that was inside Inventor just now. Okay. And that is the inlet that is generated from within Inventor. Now, coming back to Inventor. So if we have design automations, so we can amend the size or the specs almost immediately. Okay. And we can even export to Revit family almost immediately if the automations has been set up and configured. Okay, so you can see here all the information, details, we carry over from Inventor to Revit now. Okay, so that is how we export the RFA files or the RFA from Inventor. So this is Vault. So Vault is used to manage the files, the data. So now I'm adding in the attachment earlier as reference in case the RFI attachment are required. Okay, so another benefits that for this is so the Inventor and Revit combines everything their files together for coordinations and clash detection. You can always use Naviswork. You can bring both files from both worlds, coordinates it inside Naviswork. Okay, so that you can do the clash detection, and you can do something like this, which is the what you call it, visualizations to send or to share to the related stakeholder or to your customer to show, oh, the equipment is looking like this in this factory or in this buildings. Okay, so the end product will look something like this. So this is done through Naviswork Manage and also the Autodesk rendering from within Naviswork Manage. Okay, so we can use this and share these files or videos or link, okay, to share to our customer so they can view it by scene. Okay, so it's not like the VR content where you can walk through. It's not that, because for that you require the VR device. But for this, you can generate it and it can be viewed using your phones or even your PC tablets. Okay, so you can view it and then you can collaborate and markups and review the design together. So this is the process. So we go to Naviswork Manage and then we can do the cloud rendering from Naviswork Manage. So how I usually do it is I just create a QR code for all the scene or all the location that I want to show or submit, and then they'll scan it and they have a better view of how it looks inside. So instead of sharing in just a screenshots or screen capture or a PDF, so we can do this now. Okay. So any questions? Okay, do you have any questions? So is everyone okay?